Example number 1, we are given the function f of x is equal to x cubed, okay? And we're asked to find f prime. Now f prime, you'll hear Mr. Adams say f prime is really the derivative. And so we've got to get used to that. I think part of the problem with trying to do the homework off of the example problems is that you guys have a tendency to just go, oh yeah, I just do this step here. But you really need to know all the definitions. So we're going to go a little heavier on the definitions. This is the derivative. It's also the slope of the tangent line. It's also the slope at a point. And there's lots of ways that we could denote that. We could call it dy dx. And there'll be some other notations. I wrote down the wrong delta y, delta x, or we could write it as dy dx. You could even say y d dx, because really that's what it is. It's the derivative with respect to x. And then another variation of that is d dx, or the derivative of f. And usually it's f of x. If we're taking the derivative with respect to x, then the function is dependent upon x. And so this is all the notations that basically mean the same thing. It's the slope of the tangent line. So now to find f prime, I already know the answer is 3x plus 2, because I'm a wizard. But to find it formally, we got to do a little bit more work. So let me show you how to do that. We said that f prime of x was equal to, and we'll just change the notation just ever so slightly. H approaches 0 of f of x plus h minus f of x all over h. So we did the f of a thing, and now we're just going to replace the a's with x's. And what this does is this will give me a function that is the slope, dependent upon the x value. In other words, because this has a slope that changes, and that change depends on x, I'm going to take the derivative, and when I do the formal derivative, what happens is it will give me an equation that is also dependent upon x that always calculates the slope of this curve. So what is f of x plus h? Well, it's just going to be x plus h cubed minus x cubed all over h. Next line, limit of this stuff as h approaches 0. Expand this. Oh, wait a minute. I don't like that. That's a lot of work. So we got x plus h cubed. That means I'm going to have to find, and let's write this out, x plus h times x plus h times x plus h. Yep. All right. So that's a lot of work. Well, let's just do it. I know that this is going to be x squared plus 2xh plus h squared. Right? If I multiply those two, so really what I need to find is x plus h times all this stuff. Does that make sense? All right, so let's do that. So I could do the grid method, and I could say x plus h times x squared times 2xh times h squared. Well, you learn something new every day. Welcome to Mr. Adams' class. So now we've got all this stuff. X, h squared. You guys double check and make sure I don't make a mistake. Like that's possible.
Yeah, if you remember that one day, I got like 3 mistakes.
All right, so now I got to combine like terms. If I've done things correctly, my like terms should be the diagonals, right? So all this stuff expands to x cubed. What's that? 3x squared plus 3x squared h, and then that's plus 3xh squared plus h cubed.
Why is it not 3x squared 2h? You know what I mean?
What do you mean?
Because it's like an imaginary one.
I'm just kidding.
So that we did all that work to get this. So I got to plug that in. So this first part here, that expanded becomes x cubed plus 3x squared h plus 3x h squared plus h cubed, and then I just got to tack on this minus x cubed all over h, okay? All right. These cancel. So on my next line, I'm going to take the limit of this stuff. But remember, if I did all my algebra correctly, I should be able to factor out an h from each one of these terms. So here's an h squared, and here's an h cubed. So my three remaining terms in the numerator all have h's. So I'm going to factor out that h, which will leave me with 3x squared plus 3xh plus h squared all over h. Did I do that right? Mm-hmm. Didn't Mr. Adams say it was going to be 3x squared?
I thought 3x plus 2, but
Excuse this interruption at this time. Would the ninth graders A through L please go to group 109? Ninth graders A through L. Thank you.
We'll just leave that in the video. So now when I cancel that out, if I take the limit of this, as h approaches 0, I'm really taking the limit of 3x squared plus 3x plus h, but I'm going to plug in a 0 for h because h approaches 0 plus 0 squared. What does that leave me?
3x squared plus
3x squared.
nothing.
Where's the plus 2?
The limit does not exist.
Okay, so that's my derivative. This, we did all that work to figure out that f prime is equal to 3x squared. So now watch this. This is going to be a pretty cool thing. To verify this data, what I'm going to do is our original function and this is where you guys need to pay attention. This is what helps you with your homework. These little tips and tricks right here. X cubed is our original function, and then we said so let me write this down on a piece of paper. I said that f of x was x cubed. Then I said f prime of x was equal to 3x squared. Somebody give me a number for x.
12.
Let's do 5. Well, I don't want it to be too big. So I've got 5 cubed, which is 125. That means that the point 5 comma 125 exist on my graph. So I'm going to have to change the window because we chose a big number. So my x value has to go up to at least 125. So I'm going to say 130, and I'm going to make my minimum value, oh wait, no,
That's your y.
that's my x. My x could be 6, and my y can be 4, and then my y value should be 120 to 130. All right, now before I hit graph, we're saying that this exists, so basically, we have this function here, and way up here, we've got the point 5 comma 125. Now the slope of the line, what the slope should be, that is based on f prime. So this function has a slope of f prime. Okay, so in other words, this is y equals f prime of x times x. You could treat this like the slope plus b. And we said that that is equal to 3x squared. So that would be 3 times the quantity 5 squared, 3 times Well, 5 squared is 25, and 3 times 25 is 75. So the slope of that line should be 75. That's a pretty steep slope. Now let's graph it first and check out and verify some things. So if I hit trace and if I plug in 5, sure enough my y value is 125. Now you might say to yourself, well, Mr. Adams, how do I know that the slope is that? Put on your thinking caps, everybody look up here because I'm going to show you something amazing. Second trace is calc. Hey, what's this? dy dx. A little notation I just showed you a few minutes ago. If I want to know the slope of the line on this curve at a particular point, I can go to calculate menu and hit dy dx. It will ask me to plug in the x value, which is 5, and then hit enter. Now the reason there's a 0.000001 is it does it algebraically by plugging in a number really, really close to 75. In other words, it does this limit business of f of x blah 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 blah, but it lets x or h approach 0.00001. So it's really f of x plus 0.00001 minus f of x all over 0.0001. But the slope is 75. Any questions?